Feedwater heater's performance. Inadequate vent. An inadequate vent in a feedwater heater traps non-condensable gases like oxygen, carbon dioxide and non-condensable air around the tubes, creating an insulating blanket. This impairs steam condensation, drastically reducing heat transfer. This operational defect negatively impacts thermal performance metrics in several ways: reduces heat transfer efficiency, lowers overall thermal performance, increases fuel consumption and cost. Another reason causes equipment stress and potentiality issues or reliability issues. Inadequate vent increases TTD, terminal temperature difference. High TTD means poor performance of feedwater heaters. So to have a good performance, we should have low TTD. How it increases? This insulating gas layer prevents the extracted steam turbine from effectively heating the feedwater. As a result, the temperature of water leaving the heater drops further below the saturation temperature of the steam. An abnormally high TTD indicates poor overall heat performance. Higher TTD is equal to poor heat transfer, equal to lower heater efficiency. TR increases. The total temperature gained by the feed water as it passes through the heater drops. Less it is transferred because the steam cannot reach the tube surface effectively. Lower TR indicates less heat transferred and reduced heater efficiency. Drain cooler approach for inadequate vent remains unaffected, as DCA measures the temperature difference between the cooled drain water leaving the heater and the incoming feed water. Because the drain cooling zone is located at the bottom of the heater and the venting issues predominantly plague the upper steam condensing and desupperating zones, the DCA largely remains unaffected. But in low liquid levels, it is also found increased.